Hey y'all, in this lesson, you're going to be learning about the law of cosines. This is going to be really helpful when you're trying to solve a triangle or solve for a missing piece of the triangle when it's not a right triangle. So when you have any type of triangle and you are given two sides and the included angle, that's side, angle, side, or all three sides, that's side, 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 then the law of cosines is going to come in handy for solving a missing piece. And basically, this is derived from the Pythagorean theorem. I don't have that included in the notes, but if you want to look that up, that's where this comes from. And we have three different laws, but they're all kind of basically the same thing. So if you can just remember one of them, then the other ones follow. But basically, the pattern here is if you're solving for side A, then you're using angle A, and then BC, BC. Side B, you're using angle B, AC, AC. Side C, you're using angle C, and so on. So you kind of get my drift there. But basically, that's the law for cosines. So we have an example here. If you have a running sheet of identities and theorems and laws, you might copy those down onto your sheet just to have handy. But it's not too hard to remember if you want to just try to remember it. All right, we have a triangle here, and this is a side angle side triangle. So that means law of cosines. Well, obviously it's law of cosines because that's what I'm teaching you in this video. But if you have a mixture of problems and you're trying to decide, am I using law of cosines or law of sines or Pythagorean theorem or whatever, then if you see side angle side and it's not a right triangle, law of cosines is going to be appropriate here. So I'm going to label this side E because it is opposite of angle E. This is side D and side F. Now my formulas use A, B, and C. So I could relabel these if I wanted to, but I'm just going to leave them because it doesn't really matter. Because remember the pattern that we have. If we're looking for side E, then angle E, I'll show you up here. If we're looking for side E, we'll call this E, then angle E goes here, which is what we were given. So we don't have side E, but we were given angle E. So again, letters don't really matter. It's the formula or the law that we're going to be using. So I'm just going to write it out with the variables, with the letters in there, and then we can plug in the measures. So E squared is equal to D squared plus F squared from here, two sides, two squared sides added, minus 2df times cosine of the angle given. I got that from up here, 2df times cosine of the angle given. And now I can sub in my information. I do not have E, so I'm going to leave that E. D is 18, F is 16.8 minus 2 times D 18, F 16.8 times cosine of angle E, which is 12 degrees. So it looks like a lot, but it's very simple algebra. We're just squaring a couple numbers, multiplying a couple numbers, very easy. So we can type this right side in the calculator, make sure it's in degree mode because we're talking about degrees, and go ahead and do that and write down what you get. So when I plugged that in, I got about 14.65633. I went a lot of decimal places because I don't want to have rounding error. And then the last step is to get rid of that squared. So to undo that, we're going to take the positive square root of this number, and only positive because we're talking about the length of a side. So the negative square root doesn't really make sense in this case. So do second square root of 14.65633 65633, and we get about 3.83. You could do all one step, second square root of 18 squared plus 16.8 squared, and finish that out. It's kind of long, but it would be one less step as far as typing. And there you go. So you could just do one step and get the same answer. But that is how you use law of cosines for side, angle, side. Again, make sure you're in degree mode. Next example, an architect is designing a kitchen for a client. When designing a kitchen, the architect must pay special attention to the placement of the stove, sink, and refrigerator. If the architect places the stove so that it's 4.2 feet from the sink and the fridge is 6.8 feet from the stove, what angle does the sink form with the stove and the refrigerator? So if you are not given a picture, then I would highly recommend going ahead and drawing a picture that represents all of that information. We were given the distances from each appliance, basically. And what we're looking for is this angle. They have gamma there for the angle. We could call it anything. But we are looking for this angle that the sink forms with the stove and the refrigerator. So this is a side situation, and it is not a right triangle. At least we weren't told that it was a right triangle. So in this case, the law of cosines is appropriate. And then we're looking for this angle. We could call this, it doesn't really matter. We could call this A, B, and C just for the sake of our formulas. And our formula says A squared equals B squared plus C squared minus 2BC times cosine A. In this case, we have it called gamma, but I could just change this to angle A like that. And then we plug in our missing pieces. So we have 6.8 squared equals 4.2 squared plus 5.7 squared minus 2 times, it's a little long, but it just looks scarier than it is. 2 times B times C times cosine A, and I don't know A. So I'm actually going to be solving for an angle in this case. I'm going to have to do a little bit of manipulation of this equation. It's not going to be nice, neat, and clean like the previous problem, but using inverses, we know how to do this, so it's no big deal. Let's clean this up a little bit. And by clean this up, I mean, let's just simplify these parts so that we can kind of shrink that down a little bit. Okay, I left the calculator up on the left side so that you can see what I did to get these numbers, but you need to be very careful with how you clean this up. So basically you need to take into consideration the order of operations. That still applies. It doesn't go away. So I did, let me pull up the tool. I did 6.8 squared, obviously, because that's on the left side. And then I squared these and added them. I actually just did it in one step, but you can see it on the left on the calculator. And then I have this minus, and then I have this multiplication here. So basically what's happening is PEMDAS says parentheses first, but I don't have parentheses. So exponents are next, then multiplication, then addition, subtraction. So I cannot, basically what I'm trying to point out here is I cannot subtract these. You're going to be tempted to subtract those first, but you can't subtract them because 47.88 is attached to cosine A by multiplication. They're married by multiplication. So I cannot subtract these as my next step. What I'm going to have to do is do some solving. So this is kind of like, if you can envision some simpler algebra, a number equals a number minus 47.88x. And we're solving for x. So in order to do that, I'm going to have to subtract this over first and then divide as my last step. So let's go ahead and do that. So at this point, I've just subtracted 50.13 over, and I get negative 3.89 equals negative 47.88 times cosine A. And we can, again, we can kind of envision cosine A as like X. And so to solve for X, we're going to divide by that coefficient. And that divides. And so now I have, I'm going to leave this. Let me see how it looks if I type it in. I dropped the negatives because it's a double negative. Yeah, that's kind of involved. So I'm going to leave this as a fraction just so that I can prevent some rounding error. I always get really nervous about rounding error. So I'm going to have 3.89 over 47.88 equals cosine A. And I'm solving for angle A, which means I'm going to have to use inverse cosine. So I'm going to take the inverse cosine of this fraction to get angle A. And so I can just type that in, make sure you're in degree mode. Second cosine of 3.89 divided by 47.88. And we get about 85.34 degrees. I don't think I had what to round to on this. So I just went to 2 decimal places, but typically you're going to be told what to go to there. So now we have the missing piece that we wanted for this problem. I will say if you're asked to solve for all of the angles, then you could use law of cosines again to find, one of these angles. And then once you have 2 angles, then you can use the sum of the angles to find the third one. But that's all I have for this lesson. I hope you enjoyed it. If you have any questions, please let me know. I'll be happy to help, and I'll see you in the next one.